Hello Ace, this is RetroTK2 and today we're learning all about lists in C#. If this is your first video in the C# series, I'd strongly suggest watching this series from the start. Card should be on your screen now. And if you haven't already, might I suggest downloading the channel files that accompany this video. Card should be on your screen once again. So let's get started. What is a list? Well, according to Microsoft Docs, a list represents a strongly typed list of objects that can be accessed by index. Provides a method to search, sort, and manipulate lists. This is, of course, the actual list class. As you can see, it uses the generics parameters, I want to say, so we can actually put in whatever object type that we want to use for this. Docs language down and talks about a couple of the examples. And it says, the default constructor is used to create a list of strings with the default capacity. The capacity property is displayed, and then the add method is used to add several items. The items are listed, and the capacity. This is, of course, talking about this actual example is, so I won't get too much bogged down into that just yet. The contains method is used to test for the presence of an item in the list. The insert method is used to insert a new item in the middle of the list, and the contents of the list are displayed again. Again, talking about the actual example there is. The default item int32 property, the indexer in C#, is used to retrieve an item. The remove method is used to remove the first instance of the duplicate item added earlier. And the contents are displayed again. The remove method always removes the first instance it encounters. The trim excess method is used to reduce the capacity to match the count and the capacity. And count properties are displayed. If the unused capacity had been less than 10% of total capacity, the list would not have been resized. I'm not 100% sure about that one, Ace. I must admit I never really used the trim excess, so yeah, I will not really worry too much about that. Finally, the clear method is used to remove all items from the list and the capacity. And count properties are displayed. Remarks. The list T class is the generic equivalent of the ArrayList class. It implements the iList_T generic interface by using an array whose size is dynamically increased as required. You can add items to a list T by using the add or add range methods. The list T class uses both an equality comparer and an ordering comparer. Methods such as contains, IndexUp, last IndexUp, and remove use an equality comparer for the list elements. The default equality comparer for type T is determined as follows. If type T implements the iEquitable T generic interface, then the equality comparer is the equals T method of that interface. Otherwise, the default equality comparer is objects.equalsObject. Don't worry too much about the equality comparers. I do want to cover that at some point in this series, although they are, I do think of it as quite an advanced topic in C#, but it is definitely important that objects can be compared to each other and their equality tested, so I suppose I will cover it at some point in this series. Methods such as binary search and sort use an ordering comparer for the list elements. The default comparer for type T is determined as follows. If type T implements the iComparable T generic interface, then the default comparer is the compareToT method of that interface. Otherwise, if type T implements the non-generic iComparable interface, then the default comparer is the compareToObject method of that interface. If type T implements neither interface, then there is no default comparer, and a comparer or comparison delegate must be provided explicitly. Again, not too worried here about the comparable stuff, yes, but very similar to the equalities stuff that we looked at just a moment ago. The list T is not guaranteed to be sorted. You must sort the list T before performing operations, such as binary search, that require the list T to be sorted. Elements in this collection can be accessed using an integer index. Indexes in this collection are zero-based, basically meaning that they start from 0. For very large list T objects, you can increase the maximum capacity to 2 billion elements on a 64-bit system by setting the enabled attribute of the configuration element to true in the runtime environment. List T accepts null as a valid value for reference types and allows duplicate elements. For an immutable version of a list T class, see immutable list T. Performance considerations. In deciding whether to use list T or array list class, both of which have similar functionality, remember that list T class performs better in most cases and is type safe. If the reference type is used for type T of the list T class, the behavior of the two classes is identical. However, if a value type is used for type T, you need to consider implementation and boxing issues. We won't be going over boxing in this series, Ace, but I guess it is important. If a value type is used for type T, the compiler generates an implementation of the list T class specifically for that value type. That means a list element of a list T object does not have to be boxed before the element can be used. And after about 500 list elements are created, the memory saved not boxing list elements is greater than the memory used to generate the class implementation. Make certain the value type used for type T implements the IEquatable T generic interface. If not, methods such as contains must call the object.equalsObject method, which boxes the affected list elements. If the value type implements the IComparable interface and you own the source code, also implement the IComparable T generic interface to prevent the binary search and sort methods from boxing list elements. If you do not own the source code, pass an IComparable T object to the binary search and sort methods. It is to your advantage to use the type-specific implementation of the list T class instead of using the array list class or writing a strongly typed wrapper collection yourself. The reason is your implementation must do what the .NET framework does for you already, and the Common Language Runtime can share Microsoft Intermediate Language code and metadata, which your implementation cannot. Fair enough, yes. F# considerations we're going to just pretty much skip over, and of course it goes down through the run through of what the actual methods are, the extension methods and all that fun stuff. It also goes a wee bit into thread safety as well, yes, which I'm not going to go into. Right, so we have seen an overview of what the list class is. Let's see this in action. Open up Unity and create a basic C# script. As always, make sure you give your script a different name than any other class in your project. I'll also be using Unity Spice for all our logouts here. If you would like to get it yourself, follow the card on your screen now and follow the instructions after that. Alrighty, lists in C#. So to declare a list, you just type out list and put in the generic parameters. I'm going to do a list of strings, type out, give your field or whatever a name, and then of course initialize it like so. You can also give it a capacity. I never do, but by all means feel free to do so. I'm sure there's probably some sort of performance benefit. I must admit I've never looked into it. Maybe I should, I don't know. Anyway, we'll leave it at that. Also, don't forget you also need to include this using system_collections.generic, and I believe, well, I don't know whether you need this one. It's coming up as saying I don't need it, so there you go, whatever. But yeah, you do need to put in system.collections.generics. Like so. So for now, we could, by all means, go in and use this like a normal, as you would any other array. So if I did s.log, like so, using our Unity Spice, this is all completely valid. We'll just change that to str. The only thing is that, of course, if I went and did attempt to log this, it's not going to do anything because there isn't anything in the actual list. So hopefully we should get to see that pretty soon. I must admit, I do love the new Unity stuff, that it is actually created like a separate packages folder for us to put all this processing stuff or purchasing stuff or standard assets that aren't anything really to do with our main assets. I think that's a wonderful touch. So with all that loaded there is, we can just drag and drop our script onto any game object in our scene and run the game. And you'll of course see that there's absolutely nothing logged because our list itself has no entries. So much like our arrays, you can go in and initialize some elements inside the list. So let's do 1. Actually, we'll do it from the 0 index, 0, 1, and of course 2. Click save, and then load it up, or rerun it, should I say. And as you can see, 0, 1, 2 is logged, as you would certainly expect. So okay, so let's see what the real power of where lists come in is. So what we can do is do strings.add, and then add in another element to our list. So this is going to add it, of course, to the end. So it's going to go 0, 1, 2, 3, like that. Okay, so now if I save it and run back in and rerun our game, you'll see that it adds the 3. Very, very easy. Is so you can also use the remove method that will remove that specific item from the list. Now this is where your I comparable and I equals comes into play, yes, but because our strings, the way that strings work, this will remove the actual 3. Let's just leave it at that, I guess. I'm also going to just extract this as a method and call it log strings. Oh, goodness sakes. Strings. Log strings, and then that means that we can just call it straight afterwards. So what we're going to expect to see here, I'll just put on collapse. It's going to go 2, 2, 2, and this will just be 1. So let's see that in action now. No collapse, okay, for now, because of the other call, of course. But okay, so 1, 2, 3, 0, 0, 1, 2, 3, then it goes 0, 1, 2. So as you can see, the actual contents of our list now only has 3 elements at this point, and has 4 elements at that point. Hopefully that seems fairly easy. Yes, you can also go in and access a particular element using the indexer part. Just do it like so, and you'll know that because this is a string, we can use the extension method of log with the Unity Spice. And now if I go back in and rerun the game, you should hopefully see that the final thing that is logged is going to be a 1. Since we are accessing the the element at index of 1, which of course in this case is the string 1. Hopefully that shouldn't be too easy, or hopefully that shouldn't be too difficult to understand this. And yeah, so let's do another thing. Let's try and add in another range. So what you can do is add in another list to a list. Like so. So let's do 3. We remove 3. So let's do 3, 4. Actually, let's take out 3, just so we ensure that 3 is removed. 4, 5, and 6, like so. And we'll just remove the logs. Why not? So let's go and have a little look at it. Jump back into Unity, press play, and go. And of course, I'm an idiot because I don't actually log anything out. So let's log some strings. Again, go back into Unity and rerun. And as you can see, it goes 0, 1, 2, 4, 5, 6. Hopefully, it's truly is as easy as that is. Strings.remove range, I believe. And you can remove the exact same range, potentially. I'm not really sure whether it allows you to remove a completely new, because these are 2 different lists. Well, actually, I don't even think it's allowing me to do that. Okay, so you can only remove an actual... yeah, that makes sense. So you can only remove a range from a specific index. We could do 2, and then you give it a count, which could be 3, and then it should go through and remove. What's it going to remove? I believe it will remove 2, 2, 3. I believe it's going to be removing 2, 4, and 5. Could be wrong here, yes, but let's go and have a little look at that, and let's just log out the strings again. So 2, 4, and 5 is meant to go, and as you can see, it completely goes this. So yeah. Pretty much as you would expect. Okay, so let's do another trick as well. Let's get rid of all that so that now we've got 0, 1, and 2. And now let's go and remove 1. So let's just simply go in, click remove, type in 1, and then we'll log out the strings. And what we're expecting to see is 0 and 2 being logged as. So yeah, as you can see, it's pretty much I mean, it may seem somewhat boring, but this is unbelievably useful, especially whenever you're working with objects in Unity. Is 0 and 2 is of course logged. Once you're using objects in Unity, you can just add in certain objects. It's brilliant whenever you've got, say you've got like colliders colliding with certain other things that you want to pick up items or not pick up items. You can just add them to a list, and yeah, it's unbelievably powerful stuff, and it doesn't seem to affect performance that badly, at least on the Unity side of things. So yeah, it's pretty boss. If you want to actually check to see how many elements are in your list, just use the count property, and we're going to use the toString method just to log it out here. But hopefully what we should see is 0, 2, and then 2 for the count. I was not expecting 3. I should be expecting 3 because there is 3 elements and nothing else is happening. My fault is. Okay, so yeah, that all makes sense as you would expect it to be. You can of course create a for loop instead of a for each loop. For, how did I do? There we go, perfect. And then just use strings count instead of strings.length. It's strings.count is, and just accessing the way you would expect to. Just like so. Oh, sorry, not like that, of course. I like that. And click log, click save, comment this one out, go back in and rerun the game. And there you go, as you would certainly expect. One thing I would say is that just be careful whenever you're doing string manipulation in here. Or sorry, string manipulation. Just be careful whenever you're doing list manipulation in here, because you may find that that can be a little bit of an issue if you are doing it like this. Actually, no, it shouldn't be that bad. Yeah, it should be okay, actually. What I'm thinking is whenever you're using remove at as opposed to remove, it can be a bit of an issue, but with remove, it should be okay. Yeah, with remove, it's totally fine. I might even just put in log strings here just to make sure. But with remove at, this can be a little bit tricky. So what this is going to go and do is, instead of remove with an actual value, we're just doing remove and the actual index of the string, and then it'll go through and reorder them for you as well, which is pretty nice. So whatever was at index 2 will be moved down to index 1, and so on throughout your list. So as you can see, so it logs it again, and what happens is that it removes. Okay, so what? So I wonder if we can do I gotta tell you what, probably the best way to do it is just to do a log out of all strings, and then do a separator like so. Dot log. That'll do nicely. Okay, so let's go and just have a little look here. Click play. Okay, so what happens is it removes 0, which is totally fine. Then it'll skip forward in our list, so it'll add 1 to the index, which will be 1, of course. Then it's going to remove at 1. Now, it's not going to remove 1 because now 2 is at the index of 1 and 1 is at the index of 0. So what happens is 2 gets removed, and as you can see, 1 gets logged. And then our final product is that 1 is logged, since the index of 2 doesn't exist anymore. So it'll try and remove the element at index 2, but because the count of the list is just 1, it isn't going to have an index of 2, since the count would have to be 3 in order for the index of 2 to exist. Hopefully that all makes sense. Yes. So what we need to do instead is to reverse the order of our for loop. So instead of going from 0 to the actual count, we go from the count, which is the count, sorry, minus 1, which is 2, and then we minus to our I, and our loop will stop whenever I is less than 0. So whenever I equals minus 1, it's going to exit this loop, and this will work. So it'll go and remove all of the elements, hopefully. So it'll remove the index of 2 first, then it'll remove the index of 1, then it'll remove the index of 0. So as you can see, removes the index of 2, removes the index of 1, and finally removes the index of 0. So just something to bear in mind is certainly whenever you're doing list manipulation, this happens all the time to me. I always have to reverse my for loops whenever I'm doing it. One other thing is that you can't actually use remove, I believe, at all in your for each loops. Just double check that now. Because you're not allowed to manipulate the actual list, or the enumerator, sorry, should I say, whenever you are using a for loop. I will just double check that now and make sure. And I'm an idiot because there is no values in our list. So let's put that up above and track it again. And of course, as you can see, invalid operation exception, collection was modified, enumeration operation may not be executed. So in order to actually manipulate the string, you need to use a for loop base and make sure it's reversed so that as you increase the index's number or the index element's number, I don't know, whatever, the index that you're trying to actually remove, then it's getting updated in the correct order. That it should. Hopefully that all makes sense, yes. I'm pretty sure that all makes sense. I kind of want to keep that in, I suppose. Might be a pretty good idea. And yeah, okay, so I'm just going to try and think if there's anything else that I need to show you. Okay, so then, yeah, I've just had a little look online and found a couple of other things that I could show you, of course. There is the contains method. So what you can use is an if statement and check to see if your list contains a specific value. This is, of course, unbelievably useful, especially if, say, you had a collection of items in your actual list and you wanted to make sure, say, something was meant to happen if you had this special item at a specific point in your game. You can go through and just check to see if that item is actually in that particular list. So here we're just going to log out here. And let's go back in. So of course ours should pop out and say yes, of course we do have that particular item. 2 is in the list and well, all that fun stuff. And then there it is. Yes, of course, as you would expect. One last thing, perhaps. Strings.insert. You can actually insert a item if you want to. Let's do 3 at index 3. And then we'll, of course, go and just log the strings just to double check and make sure 100% that everything's working exactly as it should. And it should log out 0, 1, 2, and 3. Boom. Easy peasy, yes. And yeah, I suppose you can also use IndexUp as well. Say you wanted to find out the actual index of a specific item, such as 2. Then you know that we will get back the index, of course, should, of course, be 2. Not length log. Thank you. Yep, perfect. So let's go back into Unity and rerun. And of course, 2 comes up. All the other parameters that we can put in here is, I must admit, I've never, ever done this before. Searches for a specified object and returns a 0-based index of the first occurrence. So I guess you can add in an index to start from. So say you had two strings of 2 added to, let's double check that then, sure. We'll add this string at the front and we will see if this works. Add a 1 to start our index from, and I believe that the final index should be 2, and if we hadn't have put in that parameter, it would be 0. Because it'll try and return the first occurrence. Sorry, it's 3, which makes, of course, perfect sense since it is index of 3. So perfect. Perfect. Yes, thankfully the computer is working, even if my head is not. So I think that'll do for lists. Yes, I've gone through quite a bit of stuff there, and yeah. So as you can see, hugely powerful stuff. It doesn't have to be strings. Yes, it can of course be ints. It can of course be other classes that you've created. Just of course make sure that you initialize them correctly. Like, well, something like this, I guess, would be fine. And then of course to add to them, you would go, you know, whatever, strings dot add new, and then my class 22, something like that. Super easy, yes. Nothing too crazy with them. They work the way you would want them to work, I guess is the best way to describe them. And you know, I would always favor using strings over our array counterparts, especially within Unity. I believe under the hood, lists use a standard array anyway. And the only time that you have a performance impact is whenever you're doing your adds or removes. So whenever you are choosing or debating about whether or not to use an array or a string, or sorry, a list, it's just usually a better idea to stick with lists. You know, why bother even worrying about that hassle? So that's lists, and yeah, Rate, comment, and subscribe. Yes. Thank you so much for watching. I hope you're enjoying this series. I need to get back into this series. I've been more focusing on the Pokemon side of things, and this series has been going on for a year now. It's time to get this thing done and done. You can email me at retrotk2@gmail.com with any of your C# woes. Thank you for watching this, and I'll see you in the next video.